Hello there, Evie here. Welcome to an air-cooled build on the Cooler Master Masterbox Lite 3.1, recommended by a subscriber, so thank you very much for that, and let me know what you think about it in the comments. So I've got all the stuff laid out here which would normally go into an air-cooled build. If you fancy checking out the last build, which was a water-cooled build, in the Fractal Design Define Mini C Tempered Glass Edition, you can check the top right-hand corner. Personally, I'm interested in two things. One is buildability, so I'll add all my comments during the video as to what things I like to put into the case, pros and cons, that sort of thing as we go, and then the second is thermal, so I'll be testing this case and comparing it against all the other cases tested so far. It's about 6 or so. If you want to check those out, then feel free. I wouldn't go too far back though in terms of the timeline of when they were recorded, because they get a bit dodgy the further you go back. So I'll jump straight into all the builds and stuff and let you know exactly what I feel. So hopefully you'll get everything you need to know about this case before deciding whether you want to buy it or not. And I may perhaps recommend something different at the end. So thanks for watching so far. Likes and dislikes through the video if you do like it or if you do dislike it, and comments especially. Let me know what you liked or what you disliked, and any support will be great. You've been great so far, and I thank you very much for that. So I'll catch you during the commentary in the middle and at the end for a wrap up, and I'll see you then. Like I said, here are the usual suspects involved in all air-cooled builds. This is also my current system I use for editing, encoding, and uploading all my content to YouTube. It's also used for general storage and the occasional gaming session. For thermal testing later, we'll be checking out the i7-6700K processor being cooled by the Hyper 212 Evo and 2 EK Vardar fans. For the GPU, we'll be testing with the R9 390X, which is a well-known high heat output card, and we'll be testing this case and comparing those test results to all the other cases tested so far. This will give us a good idea of how this case copes with a high heat output system. So with that all out of the way, here we go. The packaging for this case is pretty standard hard foam, but at this price point of around £40 or $50, I can't really complain. The Masterbox Lite 3.1 is a micro ATX case, so by default it's only designed to fit mini ITX and micro ATX motherboards. At the top you can find a pretty typical front I/O layout, which includes the reset button, separate headphone and microphone jacks, the power button, and both USB 3.0 and 2.0 ports. The far side panel features a punched out section which should help with cable management, but we'll see more of that later on. And the rear shows a bottom mounted power supply unit position, with a glimpse of the PCI Express slot covers and included rear fan. Now let's take a closer look at the front ventilation. You may have noticed earlier that there was a very slight amount of ventilation space underneath the front I/O, but the main ventilation area is to be found at the bottom. Through what looks like the mouth of a deep sea fish is a grill for the ventilation. We'll see how this copes with the thermal testing later on. By flipping the case onto its back, we can see the rubber feet, as well as the optional holes for the hard disk drive cage position, and moving a little further down to the rear, we can also find the power supply unit intake filter. And just before we remove the plastic side panel, here's something I wanted to point out. You may have noticed just then that the top is completely sealed off. There's no points for ventilation or airflow to get through. There's no points inside where you can attach fans for some sort of rear shroud exhaust from the top. So this would suggest that this case is definitely for the budget to mid-range computers. Okay, so removing the side panel requires 4 thumb screws to be unscrewed. What is a little annoying is the lack of some sort of shelf to hold the panel when all the screws are removed, which means you have to touch the panel more than ideal, which means you need to wipe it down to remove fingerprints, which then causes static charge that gets dust stuck to the panel. Anyway, here you can see the attached rubber washers and some sort of knurled border to the side panel, which also has a few foam pads dotted around to reduce vibrations. So, as for the internals, to the rear is the power supply unit slot and all of the PCI Express slots with removable and replaceable slot covers, which is really appreciated at this price point. Above those is the included 1000 to 1200 RPM rear fan, which will find its performance out later. Quickly removing the front I/O cables, we can get a clearer look at something that I've not seen in any other cases so far. To the side of the power supply unit's position is an offset panel, which from what I can tell is there to pick up excess cables from the power supply unit. We'll see if that works later on. And to the other end of the case is the 3.5-inch hard disk drive cage, which we saw the mounting holes for on the base earlier. We'll be seeing a little more of both of these later. As with most cases, the other solid side panel can be removed with 2 rear screws. I've got some opinions about the side panel which I'll show you a little bit later on. Anyway, you can probably see the cable management options in this case are vast, keeping in mind the recessed panel supplied by the power supply unit offset position to the lower right. However, I'm a little unsure what these rectangular cutouts are for. If any of you know, please let me know in the comments below. I initially thought they could be used for reservoir mounts, but there doesn't appear to be any explanation in the manual. Removing the front panel is a simple case of grabbing the recesses at the top and bottom and pulling away from the chassis. It doesn't take too much effort to do and is well designed for this approach. Before we get into the building, we'll take a good look at all the included accessories. The two large sets of panels to the left are replacement options to the red panels we saw earlier. If you really wanted a different colour for your build theme, you could spray paint or plasti dip either of them. Also included is a decent set of screws for a couple of 3.5-inch hard disk drives, the motherboard mounts and a single 2.5-inch drive, and of course an assortment of cable ties for cable management. Alright, with the formalities out of the way, let's get on to the build. For one reason or another, I generally find installing the power supply unit is a great place to start. The Dark Power Pro 11 is a little longer than the standard ATX power supply unit, clocking in at 180mm. I tried to get away with a quick installation, but with that extra bulk it wasn't quite possible. I like to try and fit in this larger power supply unit before settling for a standard 160mm ATX power supply unit, just to see how far these cases can go. And if I can fit in this larger power supply unit, then it's gonna work for any smaller ATX compliant power supply unit. Anyway, I had to settle by disconnecting all the pre-connected power cables. This isn't a criticism of the case, just the fact that the hard disk drive cage doesn't need to be removed or moved to the further slot to accommodate this power supply unit is something I'm actually impressed with. So with the power supply unit out of the way, it's time for the motherboard with its pre-installed CPU, CPU cooler and RAM, which is best installed when the case is laid down flat. Installing the included motherboard standoffs was an obstruction-free process, which is something you can't take for granted in all cases. And of course, making sure the rear I/O shield is in position is something that can easily be forgotten. Lowering the system onto the motherboard standoffs was again a relatively obstruction-free process, and was well assisted by the two pre-installed posts. Don't be too weirded out by lowering it in by the cooler. It's well secured to the motherboard by the backplate and doesn't cause the motherboard to flex. So, now the motherboard is in, we can blast through securing it in place with the included screws into the standoffs, including into the centers of the two pre-installed posts. Now is as good a time as ever to install the front I/O cables into the motherboard. It at least gets them out of the way. All in all, we have a front speaker and mic jacks, the USB 2.0 port and the 3.0 port, and the front I/O button and light cables. And now for what I think is the biggest missed opportunity of this case, the hard disk drive cage. Dismounting it is as simple as removing a total of 6 screws, which include 4 from the base. Keep in mind that the cage can be moved forward in the case to the holes towards the front. Weird that they didn't go for slots. The other 2 screws can be found inside the case, securing the hard disk drive cage to the motherboard tray. Now with the hard disk drive cage out of the case, this is where things get interesting. Something that I hadn't looked into previously was the support for 2.5-inch hard disk drives. Normally when a case can support a couple of 3.5-inch hard disk drives, this also means it can support 2.5-inch hard disk drives in those slots. However, this case goes a little against the grain by not supplying hard disk drive sleds that slot into the cage. Instead, the inside of the cage only officially supports 2 3.5-inch hard disk drives, which would be secured in place by the thumb screws provided. So to be able to fit in the 3 2.5-inch drives I regularly use, I needed to get a little bit creative. So to prevent any potential issues with contact to the steel fins inside the cage, they were covered up by electrical tape. For the sake of time, you won't see all of them covered, but that's what ended up happening. With all the fins or shelves covered, the 2 smaller drives can be mounted to the side. Since I don't possess the perfect length of correctly threaded screws, I used rubber washers to make up the difference. The solution kept the drives well secured inside the cage, however I was only able to secure 2 screws into each drive, which is not ideal. So with both drives expertly mounted to the insides of the cage, the larger spinning drive can be mounted at the top. It would have been nicer to have the SSD here, but the larger hard disk drives should always take priority over the secure mounting positions. Now the drive cage is loaded and it's ready to go back in. I found having a double height hard disk drive on top made access to the 2 top screws a little awkward, so it was easier to remove and replace it once the screws were sorted out. Now the top 2 screws are holding the drive cage in position, we can flip the case onto its side to replace the other 4 screws. And with the hard disk drive cage back in position, for some reason I wanted to talk more about hard disk drives. Feel free to skip this one out. I know I've already talked about this way too much already, but look how little space these 2.5-inch hard disk drives take up. I mean, I'm really surprised why people use 3.5-inch hard disk drives. I mean, you saw the size of them earlier compared to these. I mean, you can get a 2TB one for the same size as your SSD, or you can get a 4TB for just twice as thick. But yeah, they just go anywhere you like, really, compared to, say, a 4TB 3.5-inch hard disk drive. They're the same same capacity, just different sizes. There is sort of some sort of word that these are potentially a little bit louder, but really, I think for a general consumer, I mean, that's all you want, really. You want something quite small and nifty to go into a nice, small and tight case. I mean, you could even throw these in MITX cases. And realistically, most people won't use more than an MITX case. Really, I mean, one graphics card. Yeah, you're going to use anything else. Anyway, I'm ratting on. This is going to be a bridge over extensive cables from the power supply unit next to it. So hopefully that's going to be a really good place to store those cables in a nice and neat fashion. Similar to, I think, the Thermaltake build, I think. Or is going to be the Focus G Mini build from Fractal Design. So anyway, this should be quite interesting. I'm quite looking forward to filling those all up. I think this is a really good solution if you're going to go for this case with this many 2.5-inch hard disk drives. So thank you very much for continuing to watch, and I will crack on. Okay, so cable management time. As usual, I'm going to skip most of this for your viewing pleasure, but I'll go over the good and bad bits about it as I'm doing it, and I'll let you know how it all goes. Interested to use the back of the power supply unit panel there, which has an extra recess from the rear of the motherboard tray, so that's going to be interesting for storing excess cables, such as the hard disk drive cage will do as well, considering we save so much space by putting the 2.5-inch hard disk drives up on the side walls of the cage. But yeah, I thought that was going to bring the video down a little bit with a bit of a sort of snag where I couldn't fit in all the stuff I normally would, and then that means when I'm editing, I always edit in these cases, and once I've done all the editing, I do my commentary, and then you'll know exactly how the case performs with like everyday usage and that sort of thing from that perspective anyway. So anyway, like I said, I'll skip over most of this. Really happy how that went yesterday. It's a big relief so that it's turned out so well. Plus, I had some really great comments from the last video, so really appreciate the support. There was one guy who said that he thinks I was going to hit something like 1 million subscribers in about 3 months' time, which I don't think is going to happen, of course. But if I get 600 by Christmas, that'll be awesome. So yeah, I'll let you guys know how it goes, of course, and you'll see bits and bobs here, best and worst bits. So I'll catch you for probably GPU installation in a second. Cable management really wasn't too difficult. I had a feeling that I'd need to use the hard disk drive cage space made earlier, but it really wasn't that necessary. Luckily, I was able to connect all the drives with a single 3-connector SATA power cable. Unfortunately, to be able to connect power to the CableMod LED lighting strips and the Silverstone 128 PWM fan hub, I needed one more SATA power connector. Also, unfortunately, I don't just have one, so I'll have plenty of leftover cable that needs to go somewhere. Since we're in the middle of cable management, we may as well connect all of the power to the main components of the system. Motherboard power is an easily accessible start. The holes next to it leave plenty of room for the large cables like this one to get through. The CPU power connectors barely reach their slots, which I'm pretty disappointed with. Since top-mounted fans are not part of this case's design, there isn't the usual cable routing option above the motherboard. Pretty disappointing. Okay, so power is sorted out for now, so next is the fan situation, which really doesn't take that long. For initial thermal testing, 2 of the 3 Vardar fans are going in the front, and the included rear fan is staying in. This will be replaced afterwards for further thermal testing. When I initially saw the length of the included fan's cable, I was pretty disappointed, but it actually turns out that it's a pretty standard length for a fan cable. It's the lack of the holes above the motherboard that makes this an issue that I've not encountered in any cases I've built so far. So to help alleviate the problem, the fan was rotated so the cable exited the top. I'm not sure why this wasn't pre-installed or designed like this before. And the only real way to make this work required blue tacking the fan hub to the ceiling of the case. And funnily enough, I've been working on this video with this setup for a week and it hasn't fallen down yet. So we finally arrived at the last component for installation, the graphics card. Again, it's nice to see the PCI Express slot covers are included. In my opinion, far too many cases around this price point have those crappy snap-off covers. Anyway, now that they're out of the way, we can slot the GPU into the top PCI Express 16X slot, which is apparently reinforced to hold extra weight, but I'm not convinced it's much stronger than a standard slot. Now the GPU is in, without colliding with any parts of the case, we can secure it in place and take some of the weight off that motherboard by replacing the 2 screws removed earlier. And to finish off the GPU, we just need to give it some power and tidy up the excess cables. So here's a quick view of the rear cable management. That space by the power supply unit was very handy for the extra SATA cables. And this is where you can see the awkward side panel connection I mentioned earlier. There are a total of 8 hooks top and bottom that need to be slotted in simultaneously. However, the punched out section of the side panel isn't big enough to compensate for the motherboard's 24-pin power connector to make this process easy. Check out the Define Mini C build to see how a side panel connection mechanism should be done. The only way I could get all the hooks in the slots at the same time was to lay the case down and use both arms to apply even pressure down both sides. A slightly off-topic point, but I definitely recommend getting a microfiber cloth to deal with all the fingerprints after all this handling. Next, the side panel window can be replaced. Since it and the front of the case are made of plastic, static is a big issue in terms of dust, so you'll need to stay on top of that with the cleaning procedure of your choice. And finally, the front panel can be punched on with ease, so let's take a quick look at the results from the thermal testing and then we'll check out the complete build. With the standard setup being the included rear fan and the 2 additional Vardar fans at the front, with the testing constraints that you can see at the top, the test was cut short due to the absolutely abominable results. After 20 seconds, the CPU hit 100 degrees and saw no signs of going down, so out of pity for the CPU and the board, I left it at that. However, the GPU managed to complete the 10-minute test. Compare those 20 seconds to the rest of the cases tested and you'll be seeing the worst thermals from any case tested so far. We'll talk more about that in a second. The question now is there any chance of improving that? The simplest option is to move on to the maximum air cooling test by filling the case with as many fans as possible and changing all stock fans to the 2200 RPM Vardar fans. Unfortunately for this case, it's only got one rear 1200 RPM stock fan to change over, and that's it, but it's worth doing to see how much can be gained with the increased airflow. So with the fan changed over, the system was initially much quieter, and under testing conditions the thermals were better, 3 times better in fact. By that I mean it took 3 times as long for the system to glue itself to the 100 degree mark, so not really much to brag about. But I'm not really that disappointed. In a case that costed a lot more I might be, but this is a budget case and it's got a couple of telltale signs that this kind of setup is idiotic. The first and biggest sign is the completely sealed top that we saw earlier, and the really small ventilation area at the front. On top of that, there isn't an optional mount for a fan at the bottom. This isn't exactly an ideal start to cool a performance-based system. And the second sign, of course, is the price. Realistically, most people in search of a case to put their £1,000 system in aren't exactly going to be looking at a £40 case with very little ventilation. So this seems to be a case for the budget to mid-range PC. A CPU with 65 watts or lower TDP should do well in this case. It may get a little toasty, but it shouldn't be too hot to cause thermal throttling. Anyway, I hope that's cleared up the thermals, so let's take one last look at the finished build before we wrap up. thank you so much for checking out the video. Please like if you liked what you saw. It helps the video and it helps me to know if I'm heading in the right direction. But if you want to talk to me directly about the case or the video, head down to the comments section below. If you liked it so much you want to see more like it, please consider checking up some more videos up in the top right. And if that isn't enough, subscribing might be your only option, and you'll have to wait a week or so until the next one. Finally, if you have any suggestions for cases or other components for future videos, please leave them in the comments below. I compile all suggestions into a vote which you can be part of by clicking the straw poll link in the video description. Thank you so much for checking out the video, and if you stick around for more, I hope to catch you in the next one.